So there's this person standing on a ledge. Bungee cord is tied to ankles. And the person now jumps off the ledge and falls 122 feet. Is that not any better?
No.
Dang it. Stupid yellow. Orange it is. Falls 122 feet before rebounding. What does it mean to rebound? Bounce back up. Okay, so this person drops 122 feet before rebounding. So this is really, that's the spot where they start to kind of go back up. Got it, okay. Consider the time that the person begins to rebound to be t equals 0. What the heck does that mean? The time that the person begins to rebound t equals 0. So where's t equals 0? Where's the time of 0 then? Where are we considering that? It seems like they're saying that's when the person starts to bounce back up. So that's when t equals 0. It's almost like somebody started a timer as soon as they hit the bottom. Technical difficulties. Sorry about that. Still having them. They're about to be fixed. Okay, so this was 122 feet. I couldn't see all that on the screen. All right, so where are we at? All right, the person rebounds to a distance of 46 feet. What does that mean? What would it look like? Show me with your fingers. Yeah, they don't come all the way back up to the ledge. Thank God, right? Because then they'd hit their head. And they probably don't bounce off to the side either. I'm just showing it that way so I can see the two different things. So they bounce so that they're 46 feet still from the ledge. Okay. Sweet. After 3 seconds. So that means that they end up here at 3 seconds. So they're right here at 3 seconds. Okay. Sweet. Assuming the motion continues indefinitely, write a function that represents the person's distance from the ledge as a function of time. How many people tried to write the function right away? How many people did something different? How many people didn't even try this question? Good, everybody up. It's likely, so if you think about it, this is pretty tough because we're trying to go from just a picture of what's happening to writing an equation. So what do you wish you had instead? Is there something that might help us write an equation? Is there something that you wish you had instead of just this story? Yeah, Caden? Yeah, wouldn't it be nice if we had one of those? If I could just see a graph of this motion. That's not very straight lines. Plus, I want to go all the way down. Okay, there we go. So what would the graph look like? Do we have any points? Do we know anything about what this graph looks like at this point in time? Think about the information we have. Thumbs up once you can tell me something that we know about the graph. 1, 2, 3. Detweiler, what you got?
When I drew my graph, I started with 0, negative 1.2.
So you're saying kind of corresponding to this point right there. That makes a lot of sense. So what else do we know? What else do we know on our graph? Chloe? Yeah, can you tell me more about that maximum point? Yep. What else do we know about that maximum point? Caden?
It takes 3 seconds to get there.
Takes 3 seconds to get there. So what is the graph going to look like? Trace it in the air with your finger. Now, in theory, I did see, so Kanan did one of these. And it's probably going to look something like that in real life because we have friction and air resistance. But it says, suppose that the motion continues indefinitely. So if it actually did that, they're saying ignore air resistance, basically. Assume you've got a perfectly amazing bungee cord. That's kind of a little bad. So but I saw most people kind of making this graph in the air with their fingers. So now all we have to do is make an equation for the graph rather than an equation from that story that we have alongside, which most people typically find easier, right? We've done a lot of this. So what's something that we might know about our equation? Or what's something special about the graph that can help us? Or what can we figure out from our graph? Turn and talk really quick. So what's something that what's some information we can get from this graph? Or what's something you can tell me about our function? I'll take anything at all. Good, everybody up. Sit down once you got something. Something to give us. That's all I need. Anything at all. Good. Maddie, go. What's that? How'd you know how'd you find that the midline was at negative 84? Some people would struggle to figure out what's in between those. How did you figure that out? What? Chloe, how'd you get negative 84? So you found how far apart they are and then chopped that in half and then added it to one of the ends?
Yeah.
What's another way we could have figured out negative 84? Go back to middle school. If you're trying to find the middle of two numbers, the median. If you're trying to find the median of two numbers, what could you do with those two numbers? Like let's say I'm trying to find the median of like 2 and 5 because I had like maybe 1, 2, 5, 7, and I crossed these out. Now I need to find the median. How could I find the median? Nobody remembers? Yeah, Blake?
You add them together and then divide by the amount of numbers.
Yep, I can add them together and actually divide by 2 because there's only 2. So I could always do negative 122 plus negative 46 and divide it by 2. That didn't show for you guys. Median is the middle, which the middle of two things is really just the same thing as the average of those two things. And it still didn't show up very well. There you go. So what else can we tell from this graph? What other information can we find? Emma? Sure, so how are you going to find that? Sure. You're just saying figure out the distance between the middle and... Sure. Absolutely. And so we get what? 28? Is that right? 38? Oh. Yep. Actually, you're right. So we know the amplitude's 38. What else do we know from looking at this graph? John?
Well, it's a negative cosine graph.
Looks that way to me too.
Yeah.
Kind of has that cosine shape and definitely looks reflected. Oh, and we've already got the amplitude, so I can go ahead and say what the vertical stretch was. Although that looks horrendous. There, that's a little bit better. And then we already know where the midline is, so I can go ahead and put that at the end as well, because we know how much it was vertically shifted. The only thing I'm still missing is that. Yeah, Aiden?
So, if half a period is 3, then a full period is 6. And so, the coefficient to x would be pi over 3.
How'd you get pi over 3?
6 times pi over 3 is 2 pi.
Oh, so you're saying like 6 times that number should give us 2 pi.
Yeah.
And keep in mind, there's lots of ways to get it. I heard David say, I just kind of take pi divided by half the period. We could take 2 pi divided by the full period. We could use our equation, you know, which we had c equals 2 pi over b. Whatever works for you is great. But we do get that pi over 3 right in there. And then we are all set. What questions might you have about this problem?